Okay, truck along. I don't know, having some technical difficulties. Very frustrating. Okay. So we have our continuity and compatibility equations here, which comprise and now we need to derive the state equation, which is composed of the elemental continuity and compatibility equations, which can be reduced to the state equation. There's a substantial amount of algebra required to eliminate these variables that are neither state nor input variables. Therefore, we use the Mathematica package state, which is available on GitHub, so it's pretty easy to use if you download an example. I actually included this in there as an example, so it's up there, so you can just download it and use it, or adapt it to your problem. So the resulting system model is, here's the standard state equation, and here are the A-B matrices. So the A and B matrices, one thing that's showing up in here that wasn't defined explicitly was Km, the motor constant, which is to say a generator constant. And this is, an inductance or capacitance or something like that. So pretty standard stuff. It's one thing I did do here is, it's noteworthy, is that, and this is something I do constantly, fluid inertance is a type of generalized inductance, and sometimes I will label it with an L instead of an I, and that's just because it's hard to break old habits. So anyways, L1 is actually an inductance, a fluid inductance. So my apologies on the notation there. And we've got ourselves, this thing can be simulated very easily. We could even solve it explicitly and symbolically as well, which is pretty nice.